Hey everyone, I'm Travis Spivey, joined with my son,
Jordan Spivey, and if you're new to the channel, hit the subscribe button so you don't miss out on any of our awesome science videos. Also, scan the QR code in the top left corner of the screen to contact us and explore more of our awesome content and material.
In today's video, we will describe and explain the long-term effects of climate change. So let's do this.
Our learning target for today is, I can describe and explain the long-term effects of climate change. Before we dive into the video, let's first discuss the difference between short-term and long-term climate changes. Short-term climate changes last 1 to a few years. El Niño and La Niña are examples of short-term climate changes. Click the link above for more on short-term climate change with El Niño and La Niña cycles. Long-term climate changes last beginning from 30 years and up. This means they can possibly cause change for over hundreds, thousands, or millions of years. Scientists predict that long-term effects of climate change will include a decrease in sea ice, an increase in permafrost thawing, an increase in heat waves and heavy precipitation, and decreased water resources in semi-arid regions. In today's video, we will discuss several of many processes that can cause climate to change. These include changes in number 1, the amount of energy the sun produces over years, number 2, the positions of the continents over millions of years, number 3, the tilt of Earth's axis and orbit over thousands of years, number 4, changes that are sudden and dramatic because of random catastrophic events such as a large asteroid hitting Earth, and number 5, changes in the greenhouse gases in the atmosphere caused naturally or by human activities. Let's start with number 1.
Number 1, the amount of energy the sun radiates changes. Sunspots are magnetic storms on the sun's surface that increase and decrease over an 11-year cycle. At the peak of the cycle, about 0.1% more solar energy reaches the Earth, which can increase global average temperatures by 0.05 to 0.1 degrees Celsius. This is a relatively small change, but it can be detected in the climate record. When the number of sunspots is high, solar radiation is also relatively high. This leads to higher than normal temperatures on Earth. Overall, sunspots can on a very small level cause climate change, but not to the point where it would have a significant impact on Earth as of now. Let's check out number 2.
Number 2, plate tectonics, which is the positions of continents over millions of years. Plate tectonic movements can alter climate. Over millions of years as seas open and close, ocean currents may distribute heat differently. For example, when all the continents are joined into one supercontinent such as Pangaea, nearly all locations experience a continental climate. When the continents separate, heat is more evenly distributed across the Earth. Plate tectonic movements may help start an ice age. When the continents are located near the poles, ice can accumulate, which may increase albedo and lower global temperature. Low enough temperatures may start a global ice age. Plate motions trigger volcanic eruptions, which release dust and carbon dioxide into the atmosphere. Ordinary eruptions, even large ones, have only a short-term effect on weather. Massive eruptions of the fluid lavas that create lava plateaus release much more gas and dust and can change climate for many years. This type of eruption is exceedingly rare. None has occurred since humans have lived on Earth. Let's move to number 3.
Number 3, Milankovitch cycles, which are changes in the tilt of Earth's axis and orbit over thousands of years. The most extreme climate of recent Earth history was the Pleistocene period. Scientists attribute a series of ice ages to changes in the Earth's position relative to the sun, known as Milankovitch cycles. The Earth goes through regular changes in its position relative to the sun in the following ways. First, the shape of the Earth's orbit changes slightly as it goes around the sun. The orbit varies from more circular to more elliptical in a cycle lasting between 90,000 and 100,000 years. When the orbit is more elliptical, there is a greater difference in solar radiation between winter and summer. Second, the planet wobbles on its axis of rotation. At one extreme of this 27,000-year cycle, the northern hemisphere points towards the sun when the Earth is closest to the sun. Summers are much warmer and winters are much colder than now. At the opposite extreme, the northern hemisphere points towards the sun when it is farthest from the sun. This results in chilly summers and warmer winters. Third, the planet's tilt on its axis varies between 22.1 degrees and 24.5 degrees. Seasons are caused by the tilt of Earth's axis of rotation, which is at 22.5 degrees angle now. When the tilt angle is smaller, summers and winters differ less in temperature. This cycle lasts 41,000 years. When these three variations are charted out, a climate pattern of about 100,000 years emerges. Ice ages correspond closely with the Milankovitch cycles. Since glaciers can form only over land, ice ages only occur when land masses cover the polar regions. Therefore, Milankovitch cycles are also connected to plate tectonics. Quick checks for understanding. How do Milankovitch cycles affect global temperature? How are Milankovitch cycles connected to plate tectonics? Take 2 minutes to think, pair, and share with a partner. Be ready to share out all of your brilliant answers.
Number 4. Changes that are sudden and dramatic because of random catastrophic events such as a large asteroid impact can have a huge impact on long-term climate change. The Chicxulub asteroid impact that ended the age of dinosaurs occurred over 65 million years ago when a space rock more than 5 miles wide slammed into the Yucatan Peninsula. The crash produced a blast of intense heat that vaporized rock and set off massive wildfires. A fast cloud of ash and silt covered the atmosphere, which blocked the sun for months, years, or decades, ushering into a global winter or ice age that killed off plants and animals in a mass extinction. As you can tell, a devastating event like this can have a huge impact on global climate for many years to come.
Number 5. Since greenhouse gases trap the heat that radiates off the planet's surface, what will happen to global temperatures if atmospheric greenhouse gas levels decrease? What if the greenhouse gases increase? For more on greenhouse gases and global warming, click on the following video. But for now, a decrease in greenhouse gas levels decreases global temperatures and an increase raises global temperature. Greenhouse gas levels have varied throughout Earth's history. For example, carbon dioxide has been present at concentrations less than 200 parts per million and more than 5,000 parts per million. But for at least 650,000 years, carbon dioxide has never risen above 300 parts per million during either glacial or interglacial periods. Natural processes add and remove carbon dioxide from the atmosphere. Processes that add carbon dioxide include volcanic eruptions, animal and plant decay, burning of fossil fuel factories, deforestation, driving cars, and other various human activities. Processes that remove carbon dioxide include absorption by plant and animal tissue, and oceans absorbing large amounts of carbon dioxide from the atmosphere. Quick check for understanding. When plants are turned into fossil fuels, the carbon dioxide in their tissue is stored within them. Is carbon dioxide removed or released into the atmosphere when this occurs? How does this affect Earth's average temperature? What happens to atmospheric carbon dioxide when the fossil fuels are burned? What happens to global temperatures when the fossil fuels are burned? Take 4 minutes to write down and share out your responses. You got this. And that's our video for today. Now let's test your knowledge to see how proficient you are with describing and explaining the long-term effects of climate change by taking our video quiz.
Use your electronic device to scan the QR code at the top right of the screen, or you can click the link in the description box below the video to take the quiz.
Remember, 80% or higher for proficiency. Record your results in your proficiency sheet, and if you don't get it the first time, you better keep going because it's not over until you win.
Don't forget to hit that subscribe button, click that bell icon, and also scan the QR code to contact us and explore more of our awesome content and material.
Peace and have a positive, productive day.
If you were to go into the past, you have no idea what the consequences can be.
Bruce, I could fix things.
You could also destroy everything.